All of these are interesting indications that may imply that some intelligence designed the trajectory. So I had one sentence at the end of the paper saying, maybe the trajectory was designed. And the editor said, no, no, no. The paper will not get published unless you remove that sentence.
Wow.
So now when you listen to comet experts that say, well, this claim or that claim was never published in a peer-reviewed journal, guess what? They are the editors or the reviewers who are blocking.
3i Atlas now hides behind the sun, out of sight but not out of mind. Every major observatory with the right instruments has its gaze fixed on that region, waiting, watching. They don't say what they really think aloud. Instead, they speak in coded language, unusual outgassing behavior, non-standard spectral signatures. But if you listen closely, you can hear the tension in their voices. Something about this object refuses to fit any known category. It's not a comet, at least not one born of our solar chemistry. It's not an asteroid carved by the familiar hands of sunlight and time. It moves as though gravity itself is more of a suggestion than a rule. It sheds material in directions that don't obey logic, and yet no one can quite explain why. The most revealing image of 3i Atlas was captured on October 2nd, 2025, when it passed within 30 million kilometers of Mars. The picture was taken by the HiRISE camera aboard NASA's Mars Reconnaissance Orbiter. A remarkable moment. But here's the strange thing. On October 1st, the US government shut down. The data was taken, but it was never released. And that's where the unease begins. Not with the object itself, but with the silence surrounding it. NASA's spacecraft captured high-resolution images during the Mars pass. Those images exist. Teams have seen them. Yet the public versions we're given are blurred, low-resolution frames that reveal almost nothing. Just a faint, elongated streak surrounded by static, with the hint of motion but no definition. One researcher even wrote to the mission's principal investigator, saying, "I'm a scientist, I just want to see the data. You can do the press release later." There was no reply. Each time someone asks for higher quality versions, they're met with the same wall of bureaucratic language. Internal review cycles, image calibration, priority scheduling. And you can feel it. Behind those polite deflections, there's discomfort. Researchers, usually cool and measured, are using words like disappointing, discouraging, obstructive. The tone gives it away. This isn't about secrecy for drama's sake. It's about something real, something they cannot yet make sense of, and something that seems deliberately withheld. 3i Atlas will only visit us once. Its path is hyperbolic, not bound to our sun, not looping back. It is a traveler merely passing through, destined to drift out again into the quiet gulf between stars. That alone makes its observation window incredibly brief. And right now, that window is closing. As the object slips behind the sun, Earth loses sight of it. Only a handful of platforms, spacecraft orbiting Mars, solar probes, and a few positioned at Lagrange points still have a clear line of vision. These are the instruments capable of seeing what's truly there, of capturing fine surface detail and complex spectral patterns. The question scientists are now whispering isn't, does the data exist, but rather, why can't we see it? When rotational data began coming in, the mystery deepened. Most small bodies in space settle into predictable spins, stable, gradual, defined by sunlight, impacts, and tidal influence. But 3i Atlas, it rotates irregularly, unpredictably. Its axis drifts in a slow, uneven rhythm that doesn't line up with any known cause. It's as though the object is adjusting itself, responding to something we don't yet measure. Some researchers proposed internal density variations or uneven jets of material, what they call anisotropic outgassing. Others suggested it might have broken apart and reassembled, leaving a strange balance of mass within. None of these ideas are impossible. They simply stretch what we know. To model 3i Atlas properly, one must imagine conditions not found within our solar system, the birth of a rock in another sun's nursery, long before ours ever formed. But even that assumption leads to frustration, because the deeper scientists look, the more they're missing the one thing that matters most: high-resolution imagery. Without those clear images, theory remains just that, an idea chasing a shadow. And here is where the real problem lies, not in the science, but in the silence that wraps around it. The process of science depends on transparency, collaboration, the ability for one team to verify another's results. But when key data is withheld, everything halts. Theories can't be cross-checked, models can't be refined, the truth can't converge. So what happens instead? Speculation begins to fill the gap. Not because scientists wish to mystify the public, but because in our age, information travels faster than interpretation. When data is delayed, the story escapes into the world, incomplete, misunderstood, and ready to evolve into myth. NASA and other institutions claim caution, saying they must ensure accuracy before release. But that hesitation, seen from the outside, looks like concealment. And once trust erodes, even silence sounds suspicious. So, we arrive at this delicate balance between truth and timing, discovery and doubt. In the language of science, a pause may mean carefulness, but to the public ear, it means secrecy. And when that silence surrounds something as strange as 3I Atlas, it becomes almost alive, an invisible signal we can't help but interpret. Researchers studying 3I Atlas aren't chasing a headline, they're chasing history. Each interstellar object is a fragment of another world, a messenger carrying the chemistry of its birthplace. Inside its layers lie clues about how planets form, how stars die, and how matter travels between them. Every streak, every mineral ratio, every pattern of fracture tells a story. Carbon, oxygen, and nitrogen isotopes whisper of pressures and temperatures that no longer exist. The density of rock and ice reveals how long it drifted in radiation and silence before arriving here. To examine such a thing is to touch the earliest memory of another sun. If 3I Atlas formed in the chaos of a young star system, it might carry the building blocks of early planetary life. If it came from near a dying star, it could hold evidence of intense radiation and decay, a record of destruction turned into survival. Every possibility expands our sense of how the galaxy recycles itself. But the difficulty, once again, lies in absence. We have almost no baseline for comparison. Only 2 confirmed interstellar visitors have ever been observed, both with limited resolution, both incomplete. So when scientists turn their instruments toward 3I Atlas, they are looking at something utterly new, with no analog, no language built to describe it. That's what makes the missing data so painful, because in science, discovery is not a single spark, it's a conversation. Without open data, that dialogue falls silent. Without shared imagery, independent minds can't refine, challenge, or verify what they see. And without that exchange, progress stalls. The missing high-resolution imagery isn't just a technical problem, it's a lost opportunity. Detailed surface mapping could reveal everything: stress fractures, reflective gradients, compositional layering, even how sunlight interacts with its strange asymmetrical texture. Those fine details tell us how the object was born, whether it condensed slowly in a dusty disk, shattered in a stellar collision, or coalesced in the magnetic cradle of a dense cluster. Without those details, scientists are left to infer from afar, using faint brightness variations and incomplete spectral traces. They can model possibilities, but not truth. That's why frustration has spread through the research community. Not because anyone expects a hidden revelation about aliens or anomalies, but because they recognize that the window of observation is closing. Objects like this are rare, and they're moments of clarity, when sunlight hits their surface, when gases sublimate, when they reveal their inner structure. Those moments are brief. As 3I Atlas drifts farther from the sun, its activity will fade. The plumes of vapor that now illuminate its form will quiet. The tail will shrink. The glow that outlines its shape will vanish back into shadow. And when that happens, the opportunity will vanish too. Once the light fades and the object grows cold, no telescope can recover what was lost. A scientific window is not just a span of time. It's a combination of geometry, heat, and proximity that can never be repeated. Lose it once and it's gone forever. That's why every delay matters. Every withheld image, every unanswered request. The data that could have reshaped our understanding of interstellar formation may already be slipping into silence. The deeper truth about 3I Atlas is not only that it exists, but that it is passing. It has brushed our solar system just once in all of cosmic history, and when it leaves, it will never return. It will fade beyond the warmth of our sun, carrying its secrets into silence. And so what we choose to learn now is all we will ever know. That is why delay feels like tragedy, because knowledge, like light, has a fleeting geometry. When the alignment is right, the path is open. Miss that alignment, and the path closes forever. No technology, no telescope, no human determination can call it back. Scientists know this. They know that every observation, every image, is a conversation with time itself. When the conversation is interrupted by caution, by bureaucracy, by fear, time does not wait. The universe keeps moving, and it takes the answers with it. 3I Atlas is not only a comet or an object, it's a mirror. It reflects our relationship with mystery itself. Some see it as evidence of control and secrecy. Others see it as a reminder of our limitations, the way we try to hold infinity within our brief attention span. Both are true in their own way. What matters most is not the label we give it, but the awareness it awakens. Because through it, we are reminded that knowledge is fragile and that wonder is easily lost. We are reminded that the greatest danger is not ignorance, but the assumption that we already understand. Soon, 3I Atlas will slip beyond the range of every lens. It will cool, dim, and blend into the interstellar dark. When it does, all that remains will be the record we make now. The scattered data, the half-resolved images, the questions that still echo unanswered. If the images are ever released, they will not just show rock and ice. They will show the passage of opportunity, the trace of curiosity meeting silence. They will be the memory of a world that crossed our path and continued on its way. Perhaps that is the lesson, that the universe does not belong to us, it only visits. That we are not the keepers of truth, but the witnesses of it. And that sometimes the greatest discovery is not what we find, but what we fail to grasp before it's gone. 3I Atlas will fade, and we will move on to new discoveries, new questions, new mysteries. But for a brief moment, it asked us to look closer, to wonder again, and to remember that awe itself is a form of intelligence. What we do with that wonder will decide what kind of species we become. So watch the sky, not for proof, but for perspective, because every fragment that drifts through this vastness carries the same silent reminder that the universe is still speaking if we are still listening.